Everyday Design Decoded.
Power cords, the secret tactile code.
Okay, do this with me. Grab the cord for this lamp. Just hold it between your thumb and finger.
The zip cord? Okay, I've got it.
Now, run your fingers down the wire. You feel that? One side of the plastic is perfectly smooth, round. But the other side, it's got these little ridges, like a texture.
Ribs.
Yeah, I felt this 1,000 times and just assumed it was, I don't know, cheap manufacturing or maybe just for grip. But it's on every single lamp I own.
It is definitely not a manufacturing error. You have actually stumbled onto a hidden language. Welcome to Everyday Design Decoded. Those little ridges aren't for grip. They're a map.
A map? A map for who? Me?
Sort of. It's a map for electricity. See, inside that insulation are two copper wires. In alternating current, the stuff coming out of your wall, one wire is hot, bringing the voltage, and the other is neutral, which carries the current back.
Right, basic circuit stuff. But why does the shape of the plastic matter? If I plug in a lamp, the light turns on. Who cares which wire is which?
The light bulb cares. Or rather, you should care if you ever want to change that bulb without getting a nasty surprise.
I definitely want to avoid the surprise. What happens?
Picture the socket the bulb screws into. It has two metal contact points. There's the little button deep in the bottom center, and then there's the metal threaded cup that holds the bulb.
Okay, I'm visualizing it. Threaded cup on the sides, button on the bottom.
Now, imagine if the hot wire, the dangerous one, was connected to those metal threads. The moment you unscrew the bulb, if your finger brushed against the socket threads, or even the metal base of the bulb while it's still touching the threads,
Zip.
big zip. You become the path to ground. That metal ring is essentially live.
Yikes. Okay, I see the problem. So we want the hot wire deep inside where I can't touch it.
Exactly. Engineers designed the socket so the dangerous hot connection is only on that tiny bottom button. The threaded ring, the part you're likely to touch, is connected to the neutral wire. It's much safer.
That makes total sense. But wait, how do the ridges on the cord help with that? The wire is just wire.
Well, think about the factory worker assembling the lamp, or you if you're replacing a plug. You have two identical copper wires covered in plastic. How do you ensure the neutral wire ends up on the metal threads and not on the bottom button?
You trace the line. Oh, the ridges.
There it is. The ribbed or square edge side is the universal code for neutral. It connects to the wide blade on your wall plug, and it runs all the way up to the threaded ring on the socket. The smooth side is always hot.
So this whole time my fingers were feeling a safety manual. Smooth implies danger, ribbed implies safe.
Precisely. It's tactile engineering, keeping the energy exactly where it belongs, right under your fingertips.
Ignite your muse with drops of inspiration. Search Musedrops.